All right, guys, we are now going to be moving into solving equations. We're going to be working on solving exponential equations first, and then we're going to work on solving log equations later. And again, they're kind of, as you know, logs and exponents are kind of related. They're kind of the same thing. They're just inverses of each other, so there are a lot of similarities. But we're going to start again with exponentials. So that's what this first lesson is going to be on. And what you'll notice is the first type that we're going to see are exponential equations that have a common base. But the process in general, though, what we're going to be doing, even if they don't have a common base, which you'll see here in just a little bit, the first step is going to be to rewrite the equation using a common base. So again, the first examples already have that, so we'll be skipping that step, but then we'll start doing it later. Step number 2, we're going to use the properties of exponents to simplify each side of the equation. So again, when we get into logs, we'll use some properties of logs. You'll see that similarity. Next, we're going to use the one-to-one property, which basically states this. If I can get the bases to be the same, then I can state that the exponents are equal. So I'll be able to say that x equals y. And once we can get x equal to y, in other words, the exponents equal to each other, we just solve the equation. So long story short, make sure the bases are the same, isolate it, so it's one exponent equals one exponent, and then we can set the exponents equal to each other. So if we have some simple examples here, like number 2, you can kind of see that happening. So these first ones are fairly basic because the bases are already the same. So you'll see here I have 2 exponents, the base is both e. So that means I can use that one-to-one property, which states that 4w minus 1 equals 5 minus 2w. So I'm just going to go ahead and set those exponents equal and solve. So this is just a simple linear equation. So you add 2w to both sides. So that's 6w minus 1 equals 5. And I'll just keep going here. I add 1 to both sides. So 6w equals 6. And then w is equal to 1. What we'll start doing when we solve our logs is we're going to be checking for extraneous solutions. However, I just want to remind you we're not going to do that here because an exponential function has a domain of all real numbers. Therefore, I'm not going to have any restrictions. A logarithm, if you remember, the domain starts at 0, so there are restrictions if x is negative. So anyway, here I don't have to check that because, again, I have a domain of all real numbers. So I've got my answer and I'm done. All right, so that was number 2. Number 4, if you have some properties of logs, or not properties of logs, sorry, properties of exponents you can apply to get the exponents combined, we're going to do that. So you'll see on this one, we're going to have to combine these. On the left-hand side, I have the same base, so I'm going to use that product property, which means I can go 8 to the k squared plus k plus 2k minus 9. I'm adding my exponents. I'm going to do the same thing on the right-hand side. I'm going to add my exponents. So that's going to be 4k plus 11. So now that I have that, I can probably simplify over here. I'm going to have k squared plus 3k minus 9. And the right-hand side will stay 4k plus 11. Now that we have these combined, I have one exponent equals one exponent. I'm going to go ahead and set these exponents equal to each other. So this will be k squared plus 3k minus 9 equals 4k plus 11. Now when we solve this one, we have to realize that we're dealing with an exponential function. So in order to do that, in order to solve that, I'm going to set it equal to 0 and I'm going to factor it. So if I set it equal to 0, I'm going to move the 4k over, so it's going to give me k squared, subtract the 4k, so that's going to give me minus k. And then I'm going to subtract 11 from negative 9. That's going to give me negative 20. And then you factor this. I know that 5 times 4 equals 20. They have a difference of 1. So I have k, 5, and 4. And I'm going to need a minus 5 plus 4 to give me minus 1k. So when you solve, we get k equals 5. And we get k equals negative 4. And again, with an exponential function, there's no restrictions to your domain, so both of those answers are going to be solutions. So when you have like bases, that's what you need to do. If you don't have like bases, well, you need to make them like bases. So if you look at number 6, I don't have a like base. However, if you look at the left-hand side, I can break that down so that it has a base of 4. So I'm going to do that. I'm going to take this 64, I'm going to rewrite it as 64 to the negative 1. And let's go ahead and put that in parentheses. So that negative 1 is going to stick around. However, this 64 needs to get broken down. My goal is to make it have a base of 4. So if you don't know what it is already, you break it down until you find out. So 8 times 8 is 64, which is 4 times 2, and 4 times 2. Now notice I can combine these 2's, and if you notice, 4 times 4 times, bring those 2's together, 4 cubed is going to equal 64. So this equation simplifies to 4 cubed to the negative 1 equals 4 to the a squared minus 4. Now, I have to one more step here. I want to get rid of that parentheses, so I'm going to do the power to a power property. So this is 4 to the negative 3 equals 4 to the a squared minus 4. That's an a, not a 9. So now that I have that, I can go ahead and solve this and use that one-to-one property and set these exponents equal. So negative 3 equals a squared minus 4. Since this just has an a squared, I'm going to isolate the a squared and square root both sides. So I'm going to add 4 to both sides. I get 1 equals a squared. And remember, when you solve this, a squared equals 1. You square root it, and you're going to get plus or minus 1. So your answer on this one is going to be plus or minus 1. So that's number 6. Again, what we're doing is we're taking our bigger base, breaking it down so that it has the same base as the other side of the equation. Now, got one more here. This one's doing quite a bit, so I'm going to choose number 8 here to work out. So on number 8, we're going to have to combine these terms right here. In order to do that, we have to do a little bit of manipulation, just like I did in the last one. This is 1 over 12, so I'm going to change that so it's 12 to the negative 1, and that's going to be raised to the 4x plus 3. So this is me just dealing with that 1/12 term. So now I'm going to distribute because I'm using the power to a power property. So that's now going to be negative 4x minus 3 times 12 to the x squared. And again, I have that right-hand side. I'll copy that down here in just a second. But before I do that, I can use the product property on my left-hand side. So I'm going to go ahead and do that. So this is going to be 12 to the, and again, I'm adding these. I'll just go negative 4x minus 3 plus x squared. But I would prefer to write it like this: x squared minus 4x minus 3. And that's going to equal, I'm going to bring this guy down. I haven't really touched it this whole problem. 12 to the 2x plus 13. So there's my equation all simplified out. Now I can use that one-to-one property because I got one exponent equals one exponent. So I'm going to go x squared minus 4x minus 3 equals 2x plus 13. And again, as we did on one of the problems before, this is an exponential equation, or a quadratic equation, I'm sorry. So I'm going to set it equal to 0 and solve. So I'm going to subtract 2x from both sides. That gives me x squared minus 6x minus 3 equals 13. And I'm going to subtract 13 from both sides. So that gives me x squared minus 6x minus 16 equals 0. So now that we're able to do that, I can factor it. So I'm going to set this into two binomials. It's going to be x and x. And 8 times 2 gives me 16. They have a difference of 6, so I'm going to go minus 8 plus 2. So your answer becomes x equals 8 and x equals negative 2. And again, both those answers are going to be answers because I don't have any extraneous solutions on these. So anyway, that's again set 2. That's if you don't have a common base, that's how you would handle that. I want to try one more crazier one if I can. So we're going to look at number 16 to kind of wrap things up. And this is one where you may want to give it a shot yourself. So if you do that, you can pause it and go from there. But number 16, we have 3 different bases. So you want to see like which one you want to break it down to. Obviously, I'm going to look at the smallest number, which in this case is going to be 8. I'm going to see if I can break this down to 8. Now, if you have a calculator to speed things up, then go ahead and use it. That's fine. I'm going to go 512 divided by maybe 16, and I get 16 times 32. So when I break down my 512, I'm going to start with 16 times 32. And I'm trying to break this down into figure out how many 8s it would take to get me there. Now, if these don't break down, I know this is 8 squared. So I know I can do that one. I need to see, can I break 512 down in terms of 8? If you don't know, then you're going to have to break it down and see. So 16 is 8 times 2. 32 is 8 times 4. And you can see if I combine these guys back, I'd get 8 times 8 times 8. So I can break these all down into a base of 2. So this is going to be 8 cubed to the y squared equals, and now notice that 8 squared is on the bottom for that 1 over 64. So I'm going to call it 8 to the negative 2 to the 3y times 8 to the negative 1 to the 5y squared. One more step, or a couple more steps here. On the left-hand side, we have 8 to the 3y squared equals, on the right-hand side, I'm going to have to combine these before, or do the power to a power property before I use that product property and combine them into one exponent. So first I'm going to multiply, so that's going to be 8 to the negative 6y times 8 to the negative 5y squared. Now that I've done that power to a power property, I can now add these exponents. So it's going to be 8 to the negative 5y squared plus a negative 6y. I'm just putting it in order here from highest degree to smallest. On the left hand side, I have 8 to the 3y squared. Okay, so now that I've combined all these, I can use that power to the one-to-one property. I can set these exponents equal to each other. I don't have much room, so I'm going to go ahead and do it over here. Okay, so if I do that, I'm going to have 3y squared equals negative 5y squared minus 6y. So this is a quadratic equation again, as you can see, so I'm going to set this equal to 0. I'm going to add 5y squared to both sides. So that's going to give me 8y squared equals minus 6y, and I'm going to add 6y to both sides. Those are going to cancel, so you get 8y squared plus 6y equals 0. So this one, since there's only two terms that both have a y in it, I can pull out a GCF. We can actually pull out a 2 and a y, so I'm going to pull out a 2y, and I'm going to be left with 4y plus 3. So those are my two factors. So I end up with the first factor, 2y equals 0. So when you solve this, this is going to be y equals 0. So there's one solution. The next one is 4y plus 3 equals 0. And if you subtract 3 and divide by 4, you're going to get y equals negative 3/4. So again, that's about as crazy as I can see these getting. So that's going to be number 16, and that is solving exponential equations.